All right. So guys, thanks for having me here. I got about 30 minutes to set the stage for today. So the title of my prezo here is kind of interesting. I am working to tie the digital network architecture message that's been out for a couple of years now. This whole transformation to controller-based, intent-driven networks, to the big story that you're hearing at the launch here, the network intuitive, which is really the combination of, or the culmination of stuff that we've been doing for a couple of years. Making a transition to controller-based, making a transition from individual network element to network-wide configuration, tying analytics and insights, or what we can do to take all of the information counters and do something interesting with them back to our automation so that we can create this closed loop system. And that's really the big highline or the headline story that ties all of this together. We're going to spend time hooking those things together here as I set the stage for why, what drove us here, and then how are we making this real, right? So I got about, I don't know, 100 slides for 30 minutes. Not really, right?
Better start clicking.
Better start clicking and get rolling. We have an awesome agenda for you today. So I'm going to set the stage, but then we have a group of distinguished and principal engineers, even a Cisco fellow, going to come in and talk about their piece of the technology, and like go deep dive into that technology, and make sure that we cover in depth how these things work, and always tying them back to the various building blocks. So I'm not going to go through everybody that's there, but just tell you the idea is to make this come together for you. So, my name is Montanez. I'm a distinguished consulting engineer at Cisco. I've been here 19 years. I started in the field as a SE, working with customers back in the days when we were doing voice over IP. And the interesting thing that led me on my journey into corporate was when we were doing voice over IP, like I was a voice specialist trying to sell the application, but the thing that made deploying voice interesting was the fact that the network infrastructure always was at the edge of really supporting voice. And it showed all the funny things that went on when the network wasn't perfect. That led me into a career of defining best practices and driving fixes into the equipment. So I worked on the team that did the Cisco validated designs. I worked on the first high availability campus design, and actually I've presented for like 15 years at Cisco Live, the multi-layer campus design and those kinds of things. So I'm really close to the infrastructure and what we do there. I'm super excited about this transition of controller-based networking, because instead of everybody having their unique way of doing networks, the controller brings consistency to those deployments and makes those kind of funny at the edge things fade away so that we can focus on more interesting stuff. When I started 19 years ago, this changing the way the world works, lives, learns, and plays was on my badge. And that was like super audacious back then, right? As this vision, where are we going to go? We're just barely making like DECnet and Apple talk on the same network as IP, but we had this big desire to change the way everything happens and how the network would become integral in that was the vision. Think about what we're doing now, guys, like live streaming, sit around here, everybody. The network is in the middle of all the things we do. We're living through this transition, or this big change of what's happening. And it's driving a big change, this move to digital transformation at the business side of the house, right? And we see this happening across every industry, right? We see complex business transactions, this big stack of things when it's starting at that mobile device and changing the way that people want to do business. What's interesting here is we see it across every vertical. And we see this happening if customers or an organization doesn't change the way that they're delivering whatever service it is that they're delivering to the way that people want to consume it, somebody else will change it for them and take those customers away. And what we're trying to do with the digital network architecture is let the network get out of the way so that IT can focus on these kinds of transformations instead of doing the everyday, mundane, like boring adds, moves, and change kinds of things that happen on the network. But that's where IT today spends the majority of their time, because they haven't been able to move into making simple and automating the way that they operate their networks, right? So we partnered with IDC. Gartner is quoting that this is real, it's happening. Lots of customers are trying to make this transition, and we're right at this move to make that happen, and it's because we're reacting to the digital transformation, right? So lots of new devices coming on the network to support all those devices. The enterprise network becomes much more complex. All of those devices come on, have a much different security profile than they've had in the past. And that really is that nexus of what is causing people to think about redesigning their network, right? If we're designing our network so that a VLAN and an IP subnet is that fundamental component, that is the thing that represents policy. There's a spreadsheet someplace in the back of the room that represents what that subnet and VLAN represents, so we can write firewall rules and ACLs against it. The network just doesn't scale for us to do that. And if we're making network redesign, like how am I going to stretch a VLAN to represent a user group, and that affects spanning tree and the whole rest of my network every time I add a new user group and a set of policy, we just can't keep up with that. So what we're doing is taking a different approach to the way that we build that underlying network. So you guys have heard about software-defined access, yeah? Right, software-defined access is underlay overlay. We do the underlay automated with the controller, lay down IP connectivity and never mess with IP connectivity again, right? Then we put an overlay and put all the user traffic in that overlay. In the overlay, IP address is not important. IP address is how I find you, but it's not what I'm doing for connectivity. So I'm not worried about all of my subnetting and spanning tree and default gateway and routing connected to that, because I'm in the overlay. So I can implement policy at scale without affecting IP connectivity. All of that automated, so we have a nice drag and drop GUI to express our policy, but we're driving to address these changes, right? Once we get that connectivity in place, then we can move up the stack and really bring insights to play in the network. So we're at the beginning of this business transformation, where now that we get connectivity done, and we can implement policy at scale, we're adding analytics to the mix so that now we have a network that's always learning, right? And we're making much simpler the ability to take all of those counters that are locked away on interfaces inside of the network and make sense of those things. And actually do correlation with outside kinds of systems. So it's really powerful to build this environment that lets us scale and really change. We have a vision of getting us to this self-driving network, right? So if I can tie analytics and insights back to automation and get to the point where I give you recommendations that tell you, hey, I have recognized that the DHCP server is out of IP addresses or is about to run out of IP addresses, right-click here to fix and drive automation to fix things that are system-wide. We can really change the way that you do stuff. We have to earn the right to do that, right? We have to get your trust. We really want to get to the point where when that recommendation comes up, the right click here to fix, that the box that is there that says, you've done this 5 times. Don't ask me how to do that way. Just fix that problem for me and avoid those things, right? So that's the vision. What we see though, guys, is that most people are here really just starting to script against their network, right? Doing lots of things manual. Lots of people today still use Notepad copy-paste to configure their network, right? They have standardized configs saved away someplace. What we want to do with the digital network architecture and our controller-based platform is get you out of copy-paste for those mundane things. Let the machines do the things that they should do, repetitive, simple, over and over, and let IT move up the stack into these really cool things that can happen when we tie automation back to analytics. Most customers are here and they have to make changes, right? We're at a place in the enterprise network where we need to simplify so that we can automate. If we compare this to the data center, we all remember the days of like putting a DVD in a server and answering a whole bunch of questions, and every server was unique to itself. You don't have those options today in the data center. Large, medium, small, pick it, start laying your application down on top of it. We got to get to that same kind of simplified environment in the enterprise network, in the network elements, so that we then can automate against them. And that means there's some retooling, there's some changing to think. There's also education of the network operators to get them into this mode. And there's a transition to happen. We're just starting this journey, and the whole launch that is going on here is about doing that. So when we say the network intuitive, that it's about intent, this is how we allow you to express your intent, what you want to accomplish in the controller. Let that be communicated to the network elements, configured, and then we talk about context. And this is really where we're bringing all of the counters together in the network and using analytics and machine learning to correlate and get you these insights so that we can create this closed loop or tightly coupled system that really lets us realize that vision. And we're putting the building blocks in place to do that. To do that, we're embracing software-defined networking in the enterprise. This is not a textbook definition of software-defined networking. All right? Software-defined networking in the enterprise, it doesn't mean we're going to throw away 30 years of networking, take all the intelligence out of the network elements, and put some God box in the network that takes care of forwarding traffic. Right? The internet works because we have this big distributed system, and all of those devices make intelligent decisions about how to handle traffic, what to do about link and node failure in the environment, how to specially treat different types of traffic. What we want to do is leverage the power of that big distributed system, but leverage automation to make the things that are hard about running a big distributed system fade away into the background. Because the hardest part of running a big distributed system is making sure that all of those individual autonomous nodes are configured to your intent. Now in the past, we didn't even give you a tool to express intent. Right? If you wanted to create a network that converged sub-second, you had to hold that intent in your head, and then you had to figure out what you were going to do with completely separate and disconnected control planes. Right? Spanning tree, you had to go have a IP subnetting plan. What are my VLANs going to look like? What is the exposure that I'm going to allow myself to create to spanning tree? And then create an environment that was my spanning tree plan. Now, depending on what I did, I had a default gateway redundancy protocol that needed to back up that spanning tree VLAN environment. And I went and created my default gateway redundancy plan and aligned that control plane with my spanning tree plan so that I knew that I had reachability to my default gateway redundancy and everything was all load balanced and aligned. And then a routing protocol on top of that, right? People did that planning all on their own. They didn't have a tool to express intent. When we look at a transition like software-defined access, you say, I want sub-second convergence. I want IP connectivity end-to-end in the environment. So you express your intent. The controller takes care of configuring the underlying network infrastructure to allow that to happen. As we look at this transition to policy, we even do this kind of simplification or ability to express intent on what applications are important to me in my network. So in the past, quality of service was this like science kind of a thing, right? Everybody was a QoS expert. They knew how to do it themselves differently than everybody else. And it is a fun challenge to figure out what you want to do on every network element to prioritize your applications or not, because every network element has its unique hardware characteristics that allow it to service traffic. What we've done with the controller is give you the ability, again, to express intent. So voice and video are important to me. Netflix, even though it's a type of video, not so much. And express at a high level, then these applications are business relevant to me, so spend resources to protect them. These applications are all my best effort. I'm not going to do anything special for them. I just expect them to run. And here's a class of applications that are not business relevant to me. If there is some kind of a scarcity of resources, these are the applications that I want affected first in my environment. So very high level conversation in the application registry about what you want to do with the apps that we can recognize in the network, which is translated into configuration across the network. Wireless LAN, the campus infrastructure, and the wide area network working all the way across that environment, doing appropriate marking at the edges so that we classify that traffic, and then all of the scheduling in the middle to realize that expressed intent. Right? So making a big transition from device by device, individual configuration, having to understand all the individual components to really get you to express your intent into the network to get that done. The second half of this closed loop is then I have to turn on all the right measurements against that intent and report it up to you so that you know that voice and video were protected, and if there was congestion, Netflix was that type of traffic that was affected first, so that you can see that your intent is actually being realized by the network. And that's that closed loop environment that we're building, leveraging the controller to make this happen. This is not brand new. We've been at it for a while. We introduced APIC-EM, or the controller, back in 2015. We've been building on top of this infrastructure. We're just at the point right now where we can deliver the full-blown solutions like software-defined access and assurance, which are the deliverables that I've just been talking about with all of these building blocks. So as you see the big announcements and the demos on the showroom floor downstairs, these are the building blocks and the concepts that I'm talking about that allow you to realize that, right? We announced the digital network architecture, which is how we break up or put these building blocks together that allow us to arrive at these solutions, starting at the bottom with the infrastructure. We have some exciting innovation being delivered here at Cisco Live in the Catalyst 9K at the infrastructure level. The infrastructure is what makes all of this happen for us. We're embracing virtualization. The vBranch solution is an example of what we're doing that. Mr. Faulkner is going to come up later and talk a lot about how we're taking virtualization, starting in the branch, but driving it into the entire architecture. We've talked about automation and analytics already quite a bit. The top piece of this, cloud service management, is how via APIs and open standards we connect what we're doing at the controller level to the rest of IT. So integrating with IT service management applications and all of the other back-end systems that exist in this environment, because we realize that not just the infrastructure and the piece that we control is what is important to IT. This system needs to be connected to the rest of the back-end that IT drives, and so we're exposing everything that the controllers can do via APIs so that we can integrate with the rest of IT and make this part of the larger IT environment. As we look at what's new or what's being shared at Cisco Live this week, on top of this, DNA Center is the end-to-end experience for wired, wireless, and WAN on top of the controller. Now this is a shift from what you were getting on top of APIC-EM in the past. In the past, APIC-EM built an application that was focused at a place in the network or a problem. So we had an IWAN application, we had an EasyQuaz application. Those things were separated in their experience, and they weren't end-to-end for all of those solutions. Like IWAN was focused on the wide area network. We also had a vBranch solution that was focused on how do we do NFV. What we've done with DNAC is say, I'm going to give you one experience that looks across all of your enterprise network, so wired, wireless, and the wide area network. And the way that you manage that entire network, even if you're focused on doing things in the WAN, then you decide you're going to do those same kinds of things in the campus, are in one way across that entire experience. So DNAC is where the user experience lives on top of APIC-EM. It's also important to know that DNAC is going to allow you to get or interact with all of the controllers that are part of our system. And notice I'm saying multiple controllers. When I say that, APIC-EM is a controller that's taking care of configuration of the network elements. We also have ICE, that is a key component of the solution. It's focused on identity and what do we do about access policy. DNAC allows us to express our intent and have that reflected in the identity and user policy piece of the solution. And the last piece is analytics, something we just announced at Cisco Live, the network data platform, which is the analytics engine for this environment. So it is collecting all of the data or counters out of all of the physical infrastructure and the ancillary systems that live in our environment, right? So we're collecting syslogs, we're interacting with other systems like our DNS, DHCP servers in the environment so that we can give you a whole view of the whole system instead of just looking at the individual network elements. On top of that, there's two big announcements of solutions that are coming out here. Software-defined access, which is that packaged way to drive the campus, and assurance, which is how, as we start to deliver things on top of that network data platform, we give you some value with the initial release of this. Assurance, at its initial release, is focused on what do I do about automating the troubleshooting of various steps in the network. We're using the example of, hey, I have a DHCP server that the scope has ran out on. Today, if you were troubleshooting that problem, you could spend a lot of time looking at network infrastructure things and trying to figure out if the wireless network is broken before you actually got to the fact that somebody had messed up the sizing of a DHCP scope. If we automate the steps that somebody would go to do that, we can actually take you very quickly to, hey, we're seeing the DHCP requests go out and no responses come back. Go check on your DHCP server. Assurance is solving a whole bunch of those kinds of problems, and we'll continue to build on top of that to tell you, hey, I got clients that are flip-flopping between APs, things that you would have to really dive into and be deep troubleshooting inside of the individual network elements. But because we're monitoring all of those devices and following those checklists, we can get you right to root cause very quickly. And the initial release of Assurance is really focused on doing those things. The Cat 9K is the new hardware release. The U80P ASIC that my friend was handing out examples of earlier today. Two things to remember about this building block, the U80P ASIC, right? It is the power of the campus. When we started down this path, it was alphabet soup at L2 in the data center, right? We had SPB, Trill, Fabric Path, VXLAN was right on the horizon. We needed to build a solution that would evolve with you. We could have made some guesses and maybe been wrong, and people would deploy switches, and then we'd want to do one of those encapsulations become important in the rest of the enterprise outside of the data center, and they would have had to rip and replace to address that. Or we could have built for all of those encapsulations and had really expensive hardware, which made our costs go up and everybody else that was consuming them. Instead, we went down the path of building extensible or flexible hardware, so that U80P ASIC has a flexible parser that we can change the encapsulations that it understands with an iOS XE upgrade. And the proof is there that the 3850 and 3650 and 4K SUP 8E, that there's about 2 million out in people's networks. A year ago, we shipped a new version of iOS XE, and we were able to turn on MPLS and VXLAN in those devices, and with a software upgrade, taught networks that were already deployed how to handle a new encapsulation. Yep, that's a big deal. And we're able to then leverage that new VXLAN encapsulation to build on top and deliver SD access. And you guys will hear more about the building blocks that make that happen. And the last cool thing that's here at Cisco Live is this encrypted traffic analytics. You guys heard about this? Mm-hmm. Right? Pretty cool stuff, where we did innovation at the ASIC level to expose counters that are showing us the packet sequence of packet lengths and types, right? So we're now showing the patterns of the traffic, even though it's encrypted, but exposing those counters or the pattern of what that looks like on the wire, and getting that off the box through telemetry with enhanced NetFlow, sending that to the Stealthwatch engine partnered with Telos, so cloud machine learning to analyze those patterns, and with really high efficacy are able to identify malware even though it's encrypted on the wire. So we're not cracking the encryption and looking inside. This is not DPI. It is some really interesting data science looking at the patterns of that traffic and also the startup sequences. So there's a whole bunch of stuff that is clear text as well that we're able to look at DNS names and certificate information. Combine those things together with a big machine learning engine, and we're able to identify encrypted traffic on the wire. Super, super cool innovation. Started all the way down with the ASIC, right? So that U80P ASIC gives us the ability to get that information out of the box, enhancements that we make at the iOS level to get those counters off into the cloud system, and then existing solutions, the network as a sensor, network as an enforcer, to actually be able to then take action and do stuff about it. So we've created that first deliverable of nice innovation at the ASIC level, partnered with analytics to close that loop and do interesting things to the network. All right. So this is DNA and how it's tied back to the solution. I want to spend a couple of minutes like in Q&A, because you guys have just been pounding away on your keyboards and I've been talking 100 miles an hour. I want to make sure that I answer any questions and tie this together before the guys are going to take these building blocks and they're going to dive into each one of these things in depth. We've got somebody to talk about everything that I've covered in much more depth, but I wanted to set the concept for what is it that we're trying to do and remind you that, look, the big idea is to get to this closed loop, right? Tie all of that stuff together so that as we get this information out of the network, we tie it back to what we could do at analytics and unlock the power of the network infrastructure. Questions?
I had a question from somebody on Twitter. He was asking, how does the encrypted traffic analysis work without decryption? And I don't know. I'm guessing, that's, I mean,
so the whole point, the whole point is that we're not decrypting that traffic. We're looking at the patterns of the actual packets on the wire, right? So recognizing that there is a unique startup sequence for every protocol, and when those protocols are being abused, it stands out like a sore thumb. It looks wrong, and it's easy to identify because people are abusing the way that they're using a normal startup sequence. And so it just takes a little bit of a sample, nice machine learning to know what normal is and what an anomaly is, then just stands out like a sore thumb and lets us capture those things.
Using any of the information from OpenDNS as part of that?
So Talos is the back end for all of the security products. So Talos is that place that we're collecting and identifying what's normal and what's different. It powers OpenDNS. Yep. It powers the rest of the security suite, and we're leveraging that same back end to make StealthWatch more intelligent to do this.
Gotcha.
So this may be a question for later, but I'll throw it out anyway. The UADP that's in the 9000, is that the same UADP as the 3800s, or is this a next generation UADP?
Yeah, it is the next generation, and the guys that are coming after me are actually going to go into the details of what's there. But we're making the goodness of UADP current gen just better, right? The bigger table sizes, more things, but it is that next evolution of it. The other big innovation in the 9K is that we added an Intel processor. We went away from the ARM processor, and that's really to make the kinds of things that we're talking about with virtualization move into the enterprise campus much easier, as opposed to having to recompile things uniquely for ARM. Yeah?
Thank you.
All right. So I don't want to
one more quick question.
Make everybody late. Yeah, I'm listening.
You mentioned you have to earn our trust, to move from semi-automated to automated. Let's just say I trust Cisco. You've been doing it, 30 years. I want to go to that full closed loop. They mentioned some dates. I think September. A lot of this is going to be out. Can I do that?
Yep. So in the November timeframe, we're going to release in general availability the assurance product. The assurance product initially is going to give you recommended fixes, and over time we'll turn on more of the right click here to fix as opposed to actually automating that fix. So we're building that trust, and we're not going to force you to go there to the full closed loop system initially in the initial release, right? But the vision is to get there. Today people are just starting to embrace this environment, and we don't want to force people into that. You have to eat the elephant all in one bite. And that's the last thing I kind of want to leave with, is that, we talked about lots of stuff today. I'm going to flip through. We talked about lots of stuff today, but you don't have to start with this fully automated, closed loop, eat the elephant in one bite. Just deploying the controller gives you lots of benefit at the beginning. Right? Day zero plug and play configuration, the ability to do path trace, like click on a client and say, where does his traffic flow today? And then go look at all the counters that exist along the way. So there's lots of value just to get started in this environment, but we're absolutely building to that closed loop system. And the first examples of that are what we're doing with assurance and what you get in the software defined access solution set today.
So if I want to move to that full closed loop, am I waiting because of internal Cisco development, or am I waiting because I have to click certain options to potentially
to actually get those fixes
machine learning system?
To actually get that apply now, stop block out of the way. In the insurance product today, we just won't be enabling that. If you look at what we're doing with StealthWatch, you can actually enforce automatically in that so close that loop automatically and get out of the way. And so StealthWatch will give you the ability to do that for like malware, and you want to isolate that traffic that's been identified as malware, so you can quarantine automatically. All right, guys, I'm done, and I'm going to be joined or going to hand over the time to Mr. Zachs and Mr. Peter Jones, who are going to dive into the hardware, start at the bottom of that DNA stack, and we'll build up throughout the day. Thanks for the time, guys.